Hello. In this set of lectures, what we're going to do is we're going to look at some decision models. So these are models of how people do make decisions and how they should make decisions. And we're going to do a bunch of types. We're going to do multi-criterion decision-making models, we'll do some spatial models, and we'll do some decision theory models under uncertainty. Okay, so that's sort of the outline. Now, when we think about decision theory models, we're really doing these things for two reasons. First is normatively. Remember we talked about how models can make us better thinkers. Well, these particular models are going to help us make better choices. Remember I talked about how they can serve as a crutch. They can help us where we're sort of, because of our sort of limited ability to hold information, models can help us. That's clearly going to be the case here. So normatively, these models will be useful because they'll help us make better choices. Also, there's a positive dimension. So social scientists use these sort of models a lot to try and predict the choices that people make, whether they're policymakers or business people, right, or even entire governments. You can use these sort of models to figure out, why did some actor make the choice that he or she made. Okay, so that's sort of what this is all about. You can bring these models to data, as we'll see as well. So what do I mean by normatively using a model? Well, think about it, right? So you've got all these choices to make, whether to go to school, what investments to make, what job to take, even whether you should drive or fly somewhere, right? There's a whole bunch of choices you have to make. And these can be difficult. There can be lots of dimensions to them, and they can be made under uncertainty. So these models will help you make better choices. Which house should you buy? Should you have your wedding inside and outside or outside, right? All these sorts of choices, you can use these models to help you make better ones. Now, positively, right, I was talking about that, you can help predict what's going on. Again, you've got some politician who makes a policy choice. Maybe they make a nomination of the Supreme Court. You want to understand why did they choose that particular person. A political candidate chooses a platform. You can use these models to understand why did they choose that platform. A business makes an investment. These models will explain, why they made that investment, or maybe even tell you something about what they perceive the value of that investment to be. So these models, right, can be used in two ways. One, to help you make choices, and two, to understand the choices of others. Now we're going to do two broad classes of models. The first are multi-criterion choice models. So that's where there's lots of dimensions, and you're trying to weigh one alternative versus another. The second type are going to be probabilistic, where there's some uncertainty out there in the world. You're not sure how it's going to unfold, and so what you have to do is decide, okay, how do I balance off the risks versus the reward? Let me explain these a little bit, and then we'll get started. So suppose you're buying a car. You could be looking at the new Ford Fusion, right, which is a great car, or the Chevy Volt, also a great car. And you've got to think about, okay, how do I measure these two? How do I decide which of these two that I want to buy, right? Well, one way you could do it is you could say, okay, well, here's a bunch of criteria. Maybe there's, how comfortable the seats are, and so Ford wins on that one. And maybe this one is miles per gallon, and maybe the Chevy gets better miles per gallon. So what you can do is you have all these criteria, and you can choose the car based on these criteria. Now, alternatively, you could have a spatial model. Now, in a spatial model, what you could have is you could have an ideal point. So there could be a couple dimensions. One of them might be sort of how fast the car goes, speed of the car, and another might be how comfortable it is. Right, so let's get straight comfort here, not very smoothly. So I could want a car that's sort of moderately comfortable. Maybe I don't want it to be too comfortable because I sort of fall asleep in the car. And maybe I don't want it to be too fast because my sons are going to be driving soon and I want a car that isn't quite as speedy. So this is sort of my ideal point right here. And then I can think about how far are these cars from my ideal point. So this is distance 1 and distance 2, and I buy the car that's closer to my ideal point. So that's another way we can think about making decisions spatially in terms of distance between, how close one product or one policy is to my ideal preferences. Okay, those sort of choices, though, are, under certainty. Like we know all the attributes of the car. Oftentimes we have to make choices under uncertainty, where we don't know whether, what the future is going to hold. So, for example, I teach at the University of Michigan, great school, a lot of people want to go there, but people always ask me, should my son or daughter apply to Michigan? And you can think of that as a choice under uncertainty, right? Because you can apply or you can not apply. But if you apply, there's some probability P that you'll get accepted and some probability 1 minus P that you won't get accepted. So this decision, do I apply or do I don't apply, not apply, comes down to really what you think the value of P is and also how nice it would be to be accepted, how much you really want to go there. So you can write down these decision trees and decide, is it worth it? Does it make sense to fill out that application and pay the application fee? In addition to doing that, once we've got these decision trees, we're going to show how we can use them. Remember, one reason we write models is they let us do other stuff. Once we've written down those decision trees, we can actually compute something called the value of information. What the value of information tells us is if the uncertainty went away, so someone could tell us